This is a key to section 16.3 part A, and in each of these four problems, there are four problems here, and each of these four problems you want to solve each quadratic equation by using the quadratic formula. So notice that these are quadratic equations. Notice in each of these your leading term is x squared. So you see an x squared in all of those. So those are quadratic equations. And to solve a quadratic equation, you have to make sure, first of all, it's in standard form. So you got to make sure it's in standard form. And so when you put in standard form, it's got to look, all the terms have to be on one side. So ax squared plus bx plus c, and you have 0 on the other side. So that's standard form. Okay, so once you put in the standard form, then you can solve all quadratic equations. All quadratic equations can be solved by using the quadratic formula. And so remember, the quadratic formula is this. So here's the quadratic formula. And so you're going to say, now remember, well, let me just say what it is. It's the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, you see it a, b, and c, right? So the a is a coefficient of x squared, the b is a coefficient of x, and c is your constant. But you got to make sure that 0 is on this side. It's got to be in standard form before you substitute all these numbers into your formula. Okay, so the point being is that not all quadratic equations are factorable. So if it's not factorable, then the only alternative you have that you know of at this point is to use the quadratic formula. And there's another one where you can complete the square, but here you want to use the quadratic formula. So if you notice in number 1, it's already in standard form. So notice all the variables on one side, all the terms on one side, zeros on the other. So what you may want to do first is denote what a, b, and c are. So a is 2, the coefficient of x squared. B is a coefficient of x. Now, it's a -1, so don't say a +1 yet. You got to keep the sign, -1. And c is your constant, which is a -36. And then all you do is take these values for those letters and substitute into your formula. So we get x equal. Now this says the opposite of b. So b is a -1, then the opposite of a -1 is a +1. Plus or minus the square root of. Now when you got to make sure that this b squared minus 4ac, which is called the discriminant, you got to make sure that all that's under the square root. Okay, so that radicand, we call the radicand also. So that radicand must be under the radical expression. Okay, the radical symbol. Now, so b is negative here, so you got to put that in parentheses. Because if you don't and use your calculator is going to say that's a -1. And b squared, remember, b squared is never negative. It's either positive or 0, so you got to be careful. So put that in parentheses. Minus 4 times a is 2, times c, which is -36. All divided by, remember, you must say going from 1 to the end of that radical, you got to say divide. 2 times a, so that's 2 times 2. So I get 1 plus or minus the square root of. Okay, -1 times a -1 is a +1. Now look, a negative times a positive times a negative is a positive. Now use your calculator with this. So a negative times a positive times a negative. So you're going to say -4 times 2 times a -36 equal 288. So 1 plus 288, right? All over 4 equal 1 plus or minus the square root of 289, all divided by 4. Okay, I'm running out of room, so when I do the next, I'm going to do it on another sheet of paper. Okay, so that's going to equal 1 plus or minus. Now, 289, what I would do first is check and see if 289 is a perfect square. So remember in our lesson, what we did was we went ahead and put that in the calculator first. So we said 289, well, square root, 289, and notice what happens. I get 17. I get a whole number. So that means that 17 times 17 is 289, which means that 289 is a perfect square. So that's just 17. Now remember, since the 289 is a perfect square, then this is a rational solution. I get rational solutions. Okay, so since that's a rational solution, so since it's a rational solution, you got to split it apart. You got to tell me what they are. So you're going to say 1 plus 17 divided by 4, 1 minus 17 divided by 4. And then 1 plus 17 is 18, so I got 18 fourths. And then 1 minus 17 is a negative 16, so you get negative 16 fourths. And then reduce. All right, so then reduce. So I get 18 fourths, which is 9 halves, right? And then negative 16 fourths, which is a negative 4. So those are your two solutions. Okay? All right, so that was number 1. Okay, number 2, I'm probably going to need more room, so I'm going to put some stuff right here. So first of all, is this in standard form? No, because remember, you got to have 0 on the other side. If you're gonna substitute A, B, and C into this formula, you got to make sure that it's in standard form so you don't mess up. So standard form would be this. It would be 5x squared plus 9x plus 4 equals 0, because remember, you got to add 4 to both sides, right? To get 0 on that side. Now let's determine what A, B, and C are. So A is 5, B is 9, and C is 4. Now you got to make sure you're following you're doing the directions. You see this right here? This is factorable. And the reason it's factorable is because you had two rational solutions. So this is factorable. So if you did this without using a quadratic formula, you don't get any points because you didn't follow the directions. So you have to make sure you follow the directions. The direction says don't factor. The direction said use a quadratic formula. So you got to make sure you're following directions. Okay, so A is 5, B is 9, C is 4. So let's substitute into the formula. So x equal the opposite of B. Well, B is 9. The opposite of 9 is a negative 9. Plus or minus the square root of B, which is 9. Put that in parentheses, squared. Minus 4 times A is 5, times C, which is 4. Okay? All divided by 2 times A, which is 5. So I get negative 9 plus or minus the square root. So I'm going to simplify the radicand. So 9 times 9 is 81. Okay, let's look at this one. So a negative 4 times 5, a negative 4 times 5 times 4 equals a negative 80, right? So minus 80. All divided by 10. So now 81 minus 80 is 1. So I get, and put that here, so I get negative 9 plus or minus the square root of 1 divided by 10. What do you remember about the square root of 1? Do you remember that 1's a perfect square, right? So what's the square root of 1? The square root of 1 is 1. So that's negative 9 plus or minus 1. Oops, sorry. Negative 9 plus or minus 1 over 10. So these are rational solutions now. Rational solutions. So I expect you to split it apart. I expect you to tell me what they are. What are those numbers? What are those fractions? Okay, so I get negative 9 plus 1 over 10, and the other one's negative 9 minus 1 over 10. Negative 9 plus 1 is a negative 8. Negative 9 and negative 1 is a negative 10. Divide by 10, and then reduce. So if we reduce negative 8 tenths, you got to reduce. Negative 8 tenths and negative 4 fifths. And the other one, a negative 10 over a positive 10 is a negative 1. So those are your two rational solutions. All right, number 3. So number 3, let's put this in standard form. And remember, we need to make sure it's in descending order so you don't mess up. So if I subtract 2x from both sides, I get x squared minus 2x minus 4 equals 0. All right, now notice that A is going to be 1. B is going to be remember B is a coefficient of x, so that's negative 2. And C is your constant, so that's negative 4. Okay, let's put it into quadratic formula. So x equal the opposite of B. So B is a negative 2. The opposite of negative 2 is a positive 2. Plus or minus the square root of B squared, so negative 2 squared, put the negative 2 in parentheses, minus 4 times A is 1, times C, which is negative 4, all divided by, notice I went from 2 to the end, all divided by, make sure you extend this, all divided by 2 times a. So I get 2 plus or minus the square root of, let's simplify the radicand, negative 2 times itself is 4, right? All right, let's look at this. What's a negative 4 times a positive 1 times a negative 4? Well, that's a positive 16. All divided by 2. So I get 2 plus or minus the square root of 20, all divided by 2, right? Okay, now, when we did 1 and 2, notice that 289 was a perfect square, okay, and the square root of 289 was 17, so I ended up with rational solutions. Number 2, 1's a perfect square, the square root of 1 is 1, so again, I ended up with rational solutions. Now, number 3, 20 is not a perfect square, but remember, in previous lessons, you learned how to simplify radicals, so you must simplify your radical. So let's talk about the square root of 20. So let's discuss that. So the square, I'm going to go ahead and put that here. The square root of 20, remember, what perfect square goes into 20? What's the largest? 4. So it'll be the square root of 4 times square root of 5. So you'll agree that's 2 square root of 5. Okay? So that goes here. So I want you to note something, though. 2 plus or minus 2 square root of 5 over 2. Okay, now, simplify this if you can even further. So if you got to this point, you did pretty good. So you're almost there. You should get all your points except for the fact that if you leave it like this, you're forgetting the fact that let me go ahead and rewrite this right here. 2 plus or minus 2 square root of 5 over 2. Do y'all see that all these numbers are all divisible by 2? So if I reduce, that's 1, that's 1, that's 1, right? So the better solution, what they're really looking for, because you got to reduce, what you're looking for is to say 1 plus or minus the square root of 5. 1 plus or minus the square root of 5. And if you, in my math lab, they're gonna ask you to separate these solutions. So you could say 1 plus the square root of 5, comma 1 minus the square root of 5. Now remember, when we did this and the square root of 289, the radicand's a perfect square, you get rational, right? Since 20 is not a perfect square, what kind of solutions are those? Those are irrational. So these are irrational solutions. Okay, now let's look at this one. Okay, so that's already in standard form. It's already in descending order. So let's talk about A, B, and C. So A is 9, B is negative 4, C is 2, right? So A is a coefficient of x squared, B is a coefficient of x, and C is your constant. So I'm going to substitute to the formula. So remember the formula says the opposite of B plus or minus the square root of B squared minus 4AC, all divided by 2A. So I get x equal the opposite of b. Well, if b is a negative 4, what's the opposite of negative 4? Positive 4. Plus or minus the square root of b, which is negative 4. Put that in parentheses, squared, because negative 4 squared better be positive. If you don't put that in parentheses and use your calculator, it's going to tell you negative. All right, so be careful. Put that in parentheses. Minus 4 times a is 9, times c, which is 2. All divided by 2 times 9. 2 times a. So I get 4 plus or minus the square root of. Negative 4 times itself is 16. All right, let's talk about this. So a negative 4 times 9 times 2. So negative 4 times 9 times 2. So I get negative 72, right? So that's 16 minus 72. All divided by 18. So I get 4 plus or minus the square root of 16 minus 72 gives me negative 56. All divided by 18. All right, so now you got to see that at this point, remember I'm taking the square root of a negative number, so that's that imaginary unit, right? So remember the square root of a negative 1 is equal to I. So you got to use that, you got to use I, you got to use imaginary unit here. Okay, so I get this, 4 plus or minus I square root of 56, right, over 18. Now, can I simplify the square root of 56? First of all, is 56 a perfect square? No. Can I simplify the square root of 56? I don't know. Let's check. So I'm going to write 56 over here. Square root of 56. and that's 56, square root of 56. And I want to see, all right, let's check if 4 will go to 56. So 56 divided by 4 is 14. Yes, so I can simplify that. So it'll be the square root of 4 times the square root of 14. So that becomes 2 square root of 14. So that goes here. So it becomes 4 plus a minus. Now remember, you got to be careful, and I'm running out of room, so listen to what I'm saying. So this right here is I times 2 square root of 14, right? All divided by 18. All right, now usually though we prefer to put the I between the 2 and the square root, but I'm going to leave it like that for right now. What I want you to notice is this. Can I reduce the 4, the 2, and the 18? Yes. So I want you to think about this. I'm going to go and put that here. Put that right here. So that's 4 plus or minus 2i square root of 14 over 18. What do 4, 2, and 18 have in common? Well, they have a 2. So I can reduce all of those by 2's. So 4 divided by 2 is 2. 2 divided by 2 is 1. 18 divided by 2 is 9. So do you all agree that this becomes 2 plus or minus I square root of 14 all divided by 9? And so that's your answer. Okay, and if you wanted to write as 2 separate ones, you can, but you can leave it in that form. So if you want, oh, and by the way, this was rational, this was rational, this was irrational. Remember, these are real solutions, real solutions, real solutions. When you have that imaginary, remember that's an imaginary solution. So those are imaginary solutions. Imaginary solutions. Okay? And on my math lab, they would ask you to split it apart. So I don't have room here, but you would say 2. I'm going to do this. You would say 2 plus I squared root of 14 over 8 and the comma, and the other one would be 2 minus I squared root of 14 divided by 8. Okay? All right, so that was a lot of work here, but that was the worksheet for 16.3 Part A. And notice that follow directions, you have to use the quadratic formula for all of them, even though 1 and 2 could have been solved by factoring. 3 and 4, you could not have solved this by factoring. But since these are rational solutions, you can solve it by factoring, but that's not what the direction says. Always follow directions. Okay, that's the end of this key.